This lesson is going to look at a method for solving a system of equations using matrices. Now, there's no requirement to use matrices when solving a system of equations, but once you've got your head around this method, you may prefer it as it's quite an efficient method. But if you prefer to use elimination and keeping track of the operations you perform on the equations, that's absolutely fine. So I'll talk you through the method. Here we have three equations with three unknowns, x, y and z. In matrix form, it looks like this. Long square brackets, and notice that we record the coefficients in rows. The first column is the coefficient of x, then the coefficients of y, then the coefficients of z, and then the fourth is the right-hand side of the equation. Sometimes the matrices have a vertical line to separate the coefficients of x, y and z from the constants on the other side. Now we number the rows R1, R2 and R3, and we can perform some elementary row operations, which means that we can interchange rows, we can multiply every number in a row by the same non-zero constant. We can add a multiple of one row to another row. So it's a bit like the elimination method, but we're just working with the numbers. So to start with, if I want to eliminate this 2 here, I'm going to replace row 2 with row 2 take 2 lots of row 1. In the first column, row 2 is 2 and row 1 is 1. So if I do 2 take 2 lots of 1, that's now 0. I'm going to do that with every number in the row. So row 1 and row 3 are unchanged. 2 take 2 lots of 1 is 0. Negative 1 take 2 lots of 2 is negative 5. 1 take 2 lots of negative 3 is 7. And 0 take 2 lots of 9 is negative 18. Now that might seem a bit confusing at the moment, so I'm going to perform the same operations on the equations. It's basically the same as numbering these equations 1, 2 and 3, multiplying equation 1 by 2, numbering that equation 4 and subtracting equation 4 from equation 2. So you can see that this new second row, which we found by taking the old row 2 and subtracting 2 lots of row 1, this is the matrix form of this new equation. Negative 5y plus 7z equals negative 18. So really it's the same processes, but we're not writing x, y and z every time, and we're just keeping track of our moves by writing down what we do with the rows. Next I'm going to eliminate this negative 3 from the matrix. And to do that, I'm going to replace row 3 with row 3 plus 3 lots of row 1. Hopefully you can see why that's the case. So my first two rows will be unchanged from the previous step. And then my new row 3 is going to be row 3 plus 3 lots of row 1. So negative 3 plus 3 times 1, that's 0. 4 plus 3 lots of 2 is 10. Negative 2 plus 3 lots of negative 3, that's negative 11. And 12 plus 3 lots of 9 is 39. And again, I'll just follow those same moves over here with the equations so you can see what's happened there. We've multiplied row 1 by 3, so that's the same as multiplying equation 1 by 3. And then we've numbered that equation 5 and added together equation 3 and equation 5. So you can see what's going on in the matrix. We've eliminated the coefficients of x from 2 of the rows in the matrix, leaving us with 2 rows that contain coefficients of y and z and the constant term, which is equivalent to these two equations. So now I've got 2 equations and 2 unknowns, or in the matrix I've got 2 rows with zeros in the first column. I need to try and eliminate another coefficient from this matrix. Using the -5 in row 2, I can add 2 lots of -5 to the 10 in row 3, and that will give me the 0 that I need. So again, the first 2 rows will be unchanged, and then I'm going to replace row 3 with row 3 plus 2 lots of row 2. Now this is as far as I'm going to go with my matrix. This is now in echelon form. It's called row echelon form, which really means we've got steps and zeros in that bottom corner. I'll replicate that move over with the equations and then explain where to proceed from here. So we've doubled row 2. Now row 2 in the matrix is the equation over here with the -5y plus 7z is -18. So if I double that, I get -10y plus 14z equals -36. And I didn't number that equation before, so I'll number it equation 6 now, and this one equation 7. And then if I add 6 and 7 together, you can see that the y's cancel out and we end up with 3z is 3. From here, the two methods are exactly the same. At this point in the matrix, we remember that column 1 is our x's, column 2 is our y's, and so this third row is telling us that 3z equals 3, and therefore z equals 1. I then substitute back into the second row, which is telling me that -5y plus 7z, and z is 1, so that's 7, is -18. So -5y is -25, and y is 5. And then I substitute back into the first row, which tells us that x plus 2y, and y is 5, so that's 10. Take 3z, so take 3, equals 9. And then x is 2. Now, when working with matrices, there are no right or wrong moves as long as you multiply every number in a row by the same constant, as long as it's non-zero. You can add and subtract rows together, you can switch rows around. But there are some moves which are more efficient than others at arriving at your solution. So in this system of equations here, with the coefficients and the constant terms, it's easier to work with a matrix if the top left is a 1. So we're going to switch row 1 and row 2 so that the first element of row 1 is a 1. And then my next move will be to replace row 2 with row 2 take 2 lots of row 1. So 2 take 2 lots of 1 is 0. 1 take 2 lots of 2 is -3. -2 take 2 lots of -3 is 4. 11 take 2 lots of 17 is -23. In terms of the original equations, what we've done is multiply row 2 by 2, we'll number that equation 4, and then it's equation number 1 subtract equation 4. Remember, we're trying to get the matrix into that echelon form with zeros in the bottom left corner. So next I'm going to replace row 3 with row 3 plus 3 lots of row 1. So -3 plus 3 lots of 1 is 0. -1 plus 6 is 5. 4 plus -9 is -5. And -21 plus 51 is 30. And we just keep track here that this is now row 3 plus 3 lots of row 1. Back to the equation form now. We've multiplied equation 2 by 3, and then we've added together equation 3 and equation 6. Now I just need to do one more step, to get the third 0 in my matrix and reduce it to row echelon form. And hopefully you'll start to see why matrix form is a bit more efficient than working with the equations. I'm going to replace row 3 with 5 lots of row 2 plus 3 lots of row 3. So imagine if I had these two equations, this would be negative 3y plus 4z is negative 23, and 5y, take 5z, is 30. So I'll just call those equations 7 and 8 for argument's sake. It'd be like saying, all right, we want 5 lots of equation 7 and 3 lots of equation 8, and we'll call those equations 9 and 10, and then we'll add them together. So that would be 3 lines of working in equation form. But in matrix form, we can do this all in one go. So I want 5 lots of row 2, which is negative 15, plus 3 lots of row 3, which is positive 15. That's the whole reason for doing this, is to reduce that number to 0. 5 lots of 4 is 20, plus 3 lots of 5 is negative 15, so that's 5. Then 5 lots of row 2 is negative 115, and 3 lots of row 3 is 90, so that's negative 25. Now we're in row echelon form, and we can solve the matrix because this now can be written as 5z equals negative 25, and therefore z is negative 5. And then we can substitute into the second row, which is negative 3y plus 4z, so that's take 20, is negative 23, which means negative 3y is negative 3, and y is 1. And then into the first row of the matrix, x plus 2y, take 3z, is 17, and therefore x is 0. Going to work through one more example. If you're feeling confident, you should have a go at this using matrix form yourself. Pause the video and see how you go. So firstly, putting the equations into a matrix means writing the coefficients of x, y and z and the constants. Now remember I said that it's easier to work with a matrix if you have a 1 in the top left corner. We don't have that option here. What we do have is a 0 already in place at the beginning of row 2. And remember, we're looking for row echelon form, which means zeros below the blue steps here. So part of the job has already been done for us. What I'm going to do to get a 0 in place of the 3 there is to replace row 3 with 2 lots of row 3, take 3 lots of row 1. So that's 6 take 6 is 0, 2 take 3 is negative 1, negative 2 take 3 is negative 5, and 16 take 3 is 13. So now I've got 2 zeros in place. The final step is to multiply row 3 by 2 and add it to row 2. Now, just a word of warning here, you might be tempted to say, oh, well, negative 1 plus 1, that's 0. We could just add row 3 and row 1 together. But don't forget there's a 2 in the first column. So if we added row 1 and row 3, we'd be bringing that 2 back in, and we really want just zeros here. So 2 lots of row 3 plus row 2, there's my 0. Negative 10 plus 1 is negative 9. And 26 plus 1 is 27. Now we're in row echelon form, and we can solve the equations just as before. Negative 9z is 27, so z is negative 3. Substitute into the second row, 2y plus z is 1, and z is negative 3, so that makes y 2. And then substitute back into the x plus y plus z is 1. And substituting in gives us x is 1.